Last thing right here. Rewrite the expression so that it is not in fractional form. This is example number 7. I think it's the last example I do in chapter 2.1, example 7. When you have a function and it's got just a number 1 up here, it's got something up here, but the bottom, you have a binomial there. It says 1 plus sine x. One way that we might be able to kill it off, we might be able to get rid of it, is the thing called the conjugate. Conjugate. Now, conjugate has to do with binomials. Anytime you have a binomial, you got two pieces, and the conjugate is always going to be just changing the sign in the middle. So conjugate, the concept of conjugate, say that you had a binomial like x plus 4. Well, the conjugate will be x minus 4. You know, say that you had something like 1 plus and minus sine x. If you had something that had some negatives in it, say that you had like, I don't know, 2 minus x squared. Okay, you'd have 2 plus x squared. And say that you had a negative to start out with, like negative 4 plus 3x. The conjugate, you don't mess with that negative 4. It's just negative 4 plus 3x. Okay. So that's what conjugate means. Just write the binomial again, but change that sign in the middle. So how's the conjugate help us here? Well, you're not always, when you're working these trig problems, you're not always going to know what to do or where to start. But if you want to get rid of this fraction, or if you want to kill off this 2 pieces with trig on the bottom, you might try using the conjugate. And here's how. We're going to multiply the top and the bottom by the same thing. That's something you're allowed to do if you have a fraction. You multiply the top and bottom by the same. But I'm going to multiply it by the conjugate of the bottom. 1 minus sine x. And 1 minus sine x. Now, one thing that is awesome about when you multiply conjugate, so the top is just, you're going to do 1 times that. So the top's just going to end up being 1 minus sine x. That's just a certainty. The bottom, you're going to have to FOIL this out. 1 plus sine x and 1 minus sine x. Well, the great thing about FOILing out conjugate is when you do your F, O, I, and L, the O and I will always cancel out. So, you know, your F gives you 1 times 1. Well, that's 1. I'll write that down. I'm not going to do the O and the I, though, but see, the O would give you 1 times negative sine x, so that's negative sine x. And the I would give you sine x times 1, that's positive sine x. So the O and the I make negative sine x and positive sine x, so they cancel out. And then the last thing is you do your L. Sine x times negative sine x. That makes negative sine squared x. If you didn't get that concept of like the FOIL business, just understand this. If you're going to ever FOIL out 2 conjugates, you know you're looking at conjugates, just go, this is, look like algebra 2 here. Say you had like x minus 3 and you had x plus 3. Those are conjugates. And if you ever had to FOIL them out, well, if you know that they're conjugates, you can skip this part and that part, and you can just F and L them. This would make x squared, and skip the O and the I, and then just do the L part. That makes minus 9. So when you're multiplying conjugates, you don't have to do the F, O, I, L, just do the F and the L. All right, and this is what we get when you FOIL the bottom, or just do the F and L, because they're conjugates. How does that help us? How does that get this out of not being a fraction? Well, 1 minus sine squared x. You've got to get your brain trained to think, hey, maybe there's something I can do with that Pythagorean identity. Sine squared x plus cosine squared x equals 1. So I'm going to make a side thought over here. I'm going to do it in a thought bubble. So I'm bored and I've done too many of these notes today, so I need to be creative. Here's my thought bubble. There we go. I'm going to write sine squared x plus cosine squared x equals 1. If I could rearrange that so that one side said 1 minus sine squared x, I'd be in business. So let me see if I can do that. I want this to say 1 minus sine squared x. Well, I got a 1 right here, so if I just minus sine squared x on each side, that crosses out, and I get this. I get cosine squared x equals 1 minus sine squared x. what that means is I kind of have a new identity that allows me to say, okay, I can now, if I ever have this, if I see a 1 minus sine squared x, it can always be subbed out and replaced with this. Well, just so happen that I do. On the bottom of this fraction, I have a 1 minus sine squared x. So what I can do is change it into a cosine squared x. So I'm going to do that. The fraction now is going to say 1 minus sine x over cosine squared x. Just like that. All right, now where can we go from there? We can go a few places. Let's see. The goal is to get this to not be in a fractional form. So I'm going to go ahead and write this again. 1 minus sine x over cosine squared x, like that. There's a few different ways we can do it. According to the book, what they do is they split the fraction. Now, the thing is that makes it a little tougher is you've got on the top now you have 2 pieces, and on the bottom you have 1. That's, good in some ways, good sometimes and bad sometimes. But what we can do is, if you have 1 minus sine squared x over cosine squared x, you can split it into 2 fractions, and you can make it 1 over this, subtract sine over this. So you can have 1 over cosine squared x, and then the minus right there, and then sine x over cosine squared x, like that. Now I'm going to go back to one of these identities. I know this will be a little bit weird, might be a stretch for you, but I have 1 over cosine squared. That's not supposed to be cosine 2x. I have 1 over cosine squared. 1 over cosine squared works the same as this. If you had secant u equals 1 over cosine u, well, secant squared would equal 1 over cosine squared. So this thing right here will actually turn into secant squared x. And I know that's, then I'll put the minus, and then we'll talk about this, but I want to make sure, I'm not just making something up. You got to trust me on this. Why is that the case? Well, let's say 1 over cosine squared x is really just, it's really just a fancy way of saying 1 over cosine x, really. So 1 over cosine squared x is 1 over cosine x, And whenever I have 1 over cosine x, that's really just the same as saying 1 over cosine x times 1 over cosine x. Because you're multiplying fractions, you multiply the tops, there's 1, and there's cosine. And then each one of these, I'm going to go down now, each one of these could just turn into secant x, there, and then that just becomes secant squared x, like that. So I guess the whole point I'm trying to get at is 1 over cosine x definitely is the same as secant x. But 1 over cosine squared x also works the same way. It is secant squared x. That works the same on all of those reciprocal identities. So just keep that in mind. And then we'll go back. All right, so I had this. I split it into 2, and then I turned this into secant squared x. I still have this problem. What I'm going to do is, you saw me do it just a second ago, that cosine squared x is going to be cosine over cosine. So I'm going to turn this into sine x over cosine x. And then I'm going to actually split it into 2 fractions that are next to each other, not with an adder or subtract in the middle. This is secant squared x minus sine x over cosine x And then I'm going to take like that, and I'm going to push it over and make this like a multiply 1 over cosine x. Totally allowed to do that. It was cosine squared. I just made it cosine cosine, and then it's like I pulled it off and made it its own fraction, but it has to be 1 over, and then no plus sign or anything. You know, this is all being multiplied, so this all could mesh back together and go this way. Why would I want to do any of that crazy business? Well, because now I'm going to rewrite all of it. I got secant squared x minus, anytime you got a sine over a cosine like this, yeah, there's an identity that tells you you're allowed to turn that into something that's not a fraction. If you ever have a sine over cosine, you can turn it into a tangent. Now it has to be, it can't be sine squared over cosine, and it can't be sine over cosine squared. It has to be sine over cosine like that. Would make tangent x. And then the 1 over cosine, well, I've got that on here as well. I think we just talked about that a second ago. That turns into secant x. So that is right here. And done. Remember the point. What we were asked to do is write this thing, write the original function, or rewrite it so it's not in fractional form, and we got there. And to be honest, there are other ways that you can do it, but that's just the one way that I chose today. I try to kind of follow the book's thoughts on it as well. When they split the fraction here, there was another way we could have done it, and at some point, I'm sure we'll have that discussion. I did want to mention the one thing I said, how if you had this, say sine squared x over cosine x, you can't magically turn that into a tangent x because one of them squared is a 1 and one of them is not. But if you had this, then definitely turns into tangent squared x. Remember, this is the same as sine x, cosine x, cosine x. Sine squared x is sine x, cosine squared x is cosine, cosine. And then I could actually break it into its own two fractions. Like that. And then that would turn into tangent, tangent. So, sine squared over cosine squared does make tangent squared, but if you have like sine squared over cosine, it doesn't. What you'd want to do is make this sine sine, and then you could make one tangent out of it, but you wouldn't be able to make a tangent squared out of it. All right, that covers example